Have you ever asked an AI a simple question, only to get an answer that is confidently, completely, and just utterly wrong? You know that feeling? It's a moment that just shatters your trust. Well, today, we're putting on our detective hats to investigate exactly these kinds of mysterious AI failures, and our investigation starts right now.
And we're going to kick things off with our single most important clue. This one sentence. This is the key to solving the entire mystery. It tells us that what we've all been calling hallucination is very often not what we think it is at all.
So, let's set the stage, shall we? The crime scene is probably pretty familiar to anyone building or using AI apps today. You've got a system, maybe a chatbot or a research assistant, and it lies to you with the poise of a seasoned expert. You see, this isn't just a simple error. It's a fundamental breach of trust.
And that's really the heart of it, isn't it? The real damage comes from that confidence. I mean, if the AI just said, "I don't know," that would be one thing. But no. Instead, it confidently presents false information as solid fact, all because it was given the wrong knowledge to begin with.
Now, in any good investigation, you always have that one obvious suspect, the one that everyone immediately points their finger at. And in the world of AI, that suspect is always the same.
Of course, we blame the large language model, the LLM. It's the part that generates the text, the one that speaks the lie, so it must be the one making things up, right? Well, it's an easy assumption to make, but as we're about to see, it's an assumption that leads us way down the wrong path.
Okay, so this is where we need to stop thinking like a casual user and start thinking like an expert in system observability. We're talking about really understanding the internal state of a complex system just from the data it puts out. We've got to look past the symptom and find the real root cause, which, in this case, lies in a critical twist in the plot.
This slide just perfectly captures how we need to reframe this entire problem. The common myth is that the AI is just, inventing facts out of thin air. But the expert's reality, especially in systems that are supposed to use your own data, is that the AI was fed bad information before it ever even tried to answer your question.
So here's the crucial point. In a modern AI system using what's called retrieval augmented generation, or RAG, the LLM's job isn't to know the answer from memory. Think of it more like it's taking an open book test. Its real job is to formulate an answer based on the documents we retrieve for it. So if we give it the wrong page from the textbook, you're going to get a wrong answer. It's the classic case of garbage in, garbage out.
So if the problem is really retrieval, how in the world do we catch it? Okay, let's open up our investigator's toolkit and see how an expert gathers the forensic evidence. These are the critical signals from the system to diagnose the failure.
First up is the query embedding identity. Think of this as the unique digital fingerprint of the user's question. It's how the system translates our plain English into a set of numbers it can actually use to search for stuff. Now, if this fingerprinting process changes, like say you update the software that creates it, the system will suddenly start looking for answers in a completely different way, even for the exact same question.
Next up, we have to measure retrieval quality. The big question here is, are we actually finding the right documents? We use metrics like recall and precision to check this out. If the results you get for the same query yesterday are different from today and nothing in the data really justifies that change, you've got a huge problem on your hands called drift. And it's one of those silent failures that leads directly to wrong answers.
Then we've got to zoom in even closer, right down to the chunk level. We need to know which specific paragraphs or snippets of text are actually being used to answer questions. Because if the system starts to lean too heavily on just a few specific chunks, those can become these hidden single points of failure just waiting to cause a massive problem. And our final signal, well, this is the smoking gun: citation coverage. We absolutely have to ask, is the AI's final answer actually supported by the evidence we gave it? If the answer contains claims that you can't find in the source documents, boom, we found our retrieval failure. So here's the whole assembly line. A user asks a question, it gets turned into an embedding, we search a database to find the best document chunks, and then, and only then, do we send those chunks to the LLM to generate an answer. Our observability toolkit has to tap in at every single stage before the LLM, because that right there is where the failures almost always happen.
All right, that's enough theory. Let's apply these new detective skills to a real-world case where a production AI system went completely, totally off the rails.
So here's the crime. A customer asks a simple question about pricing. The chatbot, with absolute 100% confidence, gives them a number that is completely out of date. The customer is confused, trust is just broken, and a potential sale is gone, just like that.
And what was the team's knee-jerk reaction? Yep, you guessed it. They immediately blamed the LLM. They just said the model must have hallucinated, and they started thinking about how to tweak that final generation step.
But, and this is a big but, because they had the right observability tools in place, the real story came out pretty quickly. The investigation showed the system understood the question perfectly. The problem was that it retrieved the wrong documents. An old, outdated pricing PDF was somehow being ranked higher than the brand new one.
And here is the culprit, plain as day, index drift. Remember those digital fingerprints we talked about? Well, the team had added new pricing documents to their database, but they forgot to update the fingerprints, the embeddings, for all the documents. So as a result, the old, irrelevant information just looked way more attractive to the search algorithm. The LLM was completely innocent. It did its job perfectly with the bad information it was given. Cracking this case reveals the most important lesson of all. And it's not about a specific tool or some fancy metric. It's about a fundamental shift in how we approach debugging these incredibly complex AI systems. So the most crucial point is this. We have to shift our focus. RAG systems almost always fail in the retrieval step, not the generation step. The LLM is an expert synthesizer, okay? It's not a fact checker. It just trusts the context it's given, and its only job is to turn that context into a fluent, easy-to-read answer. And that leaves us with the one question that really separates the novice from the expert. Instead of asking if the AI acted correctly, we have to start asking this. Did the AI know the right thing before it acted? When you start asking that question, what once seemed like random, unsolvable hallucinations, they become simple, debuggable data problems. And that right there is how you build an AI you can actually trust.